Alrighty everyone, we're looking at the second problem. It says an aircraft carrier left port 30, and it says port 30, just cross off 30 and put something like port A, and traveled towards the dry dock at an average speed of 20 kilometers per hour. Sometime later, a container ship left traveling in the same direction, but an average speed of 24 kilometers per hour. After traveling for 10 hours, the container ship caught up with the aircraft carrier. How long did the aircraft carrier travel before the container ship caught up? And so we have kind of like our different cases, right? We have things that are moving away from each other, things that are kind of crashing towards each other. We have things that are moving in circles, right? And then we also have things that, eventually catch up. So which one do we have in this case here? And hopefully you can decipher by the question. It says, how long, so I'm trying to find some time, did the aircraft carrier travel before the container ship caught up? So if I catch up to you, what that means is like I started after you, and then at some point I catch up to you. So this is kind of the picture we should be drawing here, right? So we have two things here. And who left first? It looks like an aircraft carrier left first, so he's going to be AC. And then he traveled for a little bit, and because he has a line, I'm going to give him his own distance equals rate times time. And he traveled towards dry dock at an average speed of 20 kilometers per hour, so that goes here. And then sometime later, I don't know how much longer, but a container ship, so that's like the next thing that's leaving, right? So that's going to be here. That's my container ship, and he has his own distance and some rate and some time. He left traveling in the same direction, so they're both going in the same way, but he's going a little faster, which makes sense because if he was going slower, he couldn't. There's no way he could catch up if he left after the aircraft carrier. And after traveling for 10 hours, who traveled for 10 hours? The container ship caught up. That means that their arrows are actually the same, i.e., the distances are the same. So remember, when you have the same distance, leave leave D as just D over here. And so that's 20, that's 24, and okay, so what else do we have? Let's continue reading. After traveling for 10 hours, so who traveled for 10 hours? The container ship. So that means his time is 10. And also, well, actually, we don't know the aircraft carrier's time because he left before, so he has more time. How much more? I don't know. We're just filling things in. And then now the question is, how long did this guy, the aircraft carrier, travel for? So that's actually what I'm trying to find. So I'm going to call that T here. And if you notice here, so I have a couple of things, right? So I'm going to rewrite my equations now. So this is, remember, D. We're going to leave it D because their distances are the same. So I have D equals, what is this, 20T. And so far I have D equals 24 times 10. And hopefully you notice that we can actually solve for D. So you get 240. And just like before, I mean, these problems don't really change a whole lot. But, perhaps the complexity does. But this is essentially the same next step, which is we're going to use substitution to solve. We're going to plug this into D here, because our goal is to find how long did it take the aircraft carrier, how long did the aircraft carrier travel before the container ship caught up, i.e. I want the time, which is, you can clearly see, according to our setup, it's already set up to solve for T, so we plug in D, so this is 240 equals 20 times T, divided by 20, cancel, and this means, that T is equal to 240 over 20, cancel the zeros, which is 24 over 2, which is just 12. And the units, because it's in kilometers per hour, the units of time must be in hours. And now, let's check our work. And is there a 12? And we got money. The answer is A.